this lecture is going to go over naming acids. Now, two things you might want to have out: a periodic table and your ion packet. But just so we are clear, you will not be able to use your ion packet. You will not be able to use a periodic table in order to, or when you are taking these quizzes. But this will kind of help you through anything that you're not quite sure of yet. All right, so just briefly, we will do acids and bases later on in the year, but acids will produce a hydrogen ion in water, so an H plus ion. Right now, don't get too caught up in what that means. Just know that acids have hydrogens. Whenever you see a hydrogen at the beginning, it is going to be an acid. Okay, so a binary acid. So bi, you should be thinking 2. So it's an acid that has a hydrogen and one other element in it. Now, how do we name them? We're going to start with the prefix hydro. So that hydro comes from your hydrogen. Step 2, we're going to use the root of the non-hydrogen element. So like the root of chlorine would be chlor. The root of bromine would be brome. Then we're going to end with the suffix ic. So chloric, bromic. And then we're going to have the word acid at the end. So let's do some examples. HCl. So if you remember, step 1 of that was to start with the word hydro. Step 2, if you're looking at your notes there, is use the root of the element. So our element right here is chlorine, so our root is chlor. And then we add ic on the end. But we're missing something here. We're missing the word acid. Okay? Easy enough on that. So this is binary because I have hydrogen plus another element. So I know to start with the word hydro. So Br, remember, is bromine. My root of that is brome. And then I end with ic. Hydrobromic. What am I forgetting? I'm forgetting acid. So you might be thinking, like, how am I supposed to know what the actual root is? So think about that part that you drop when you change these to anions. So we could have had this be bromide. So the part that does not change in the IDE is going to be the part that does not change in the ic. Okay? All right, going the other way. Anytime you see hydro leading your word, throw an H down, okay? Get that out of the way. Now, fluoric means, because you should be looking at this prefix right here, fluor, that comes from fluorine, HF. Hydro, I see hydro, I'm going to put an H down. Iode comes from iodine, HI, HI. Okay? So, easy enough, right? Except there are a few that what we have to remember is our charges. So the ones that we looked at before, we'll look back. Fluorine as an ion has a -1 charge. Iodine as an ion has a -1, -1, -1. Sometimes you're going to see things that do not have a -1 charge. So what we have to do with those is we have to balance out our H's, which is positive, with our anion part. So hydro, put your H down. Sulfur makes us think of sulfur. What's my charge on sulfur if it's an ion? It is -2. So if this kind of goes with your ionic naming. So both things are going to have to cancel out your charges. If we have a -2 here, we need to have our H contributing +2 so they balance out. So it's H2S. Because this is now contributing +2. This is now contributing -2. Okay? So hydrophosphoric acid. I see hydro, I'm going to put an H down. Phosphoric, phosphor comes from phosphorus. If you remember, phosphorus is a -3 charge. So that means I need H3P. So just make sure that we are canceling our charges. So now we have +3, -3, which gives us an overall charge of being neutral. All right. So that's one type of our acids. The next are oxy acids. So that prefix oxy should make you think oxygen. All right, so these are going to be things that have oxygen, hydrogen, and another element. Really what we're going to be looking at is hydrogens bonded to polyatomic ions. Okay, so what must happen is our hydrogens must balance with our polyatomic charges. So once again, important for you to know your polyatomic ions, but also important for you to know what their charges are. So step 1, start with the anion or the polyatomic ion. So maybe you have nitrate, maybe you have bromite, maybe you have phosphate. Okay, we're going to start with that. And then what we do is we're going to either use the suffix "ic" or "us." Now there is a rule for this. If the ending is "ate," so sulfate, phosphate, bromate, iodate, it changes into "ic." Now, the way that you can remember this, you can think it's silly all you want, is I ate something icky. So think about if you eat something you don't like. Say ick. I ate something icky. Anything that ends in "ate" is going to change into "ick." Now our other one. Oh, this should say, let me fix this here. This should say "ite" goes to OUS. So maybe you don't like my "I ate something icky." Maybe you need another thing to remember. Dynamite, ITE, dynamite is dangerous, OUS. I ate something icky, dynamite is dangerous. So you should always remember what changes to what here. Then we're going to end with the word acid. So notice the word hydro is not included here. So it's a little bit different than what we've seen before with the binaries. So let's take a look at some examples. HNO3. First thing to identify is, what is NO3? So now what we have to do is know what our ions are. So if you remember, NO3 is nitrate. So what I'm going to do now, I'm going to get rid of my 8 and I'm going to change my 8 into ic. Nitric, and now I just add acid. Okay. First thing I got to do, identify my ion, NO2. So it's very close to NO3. NO2 is nitrite. So I got to get rid of my ite. And what does my ite change to? Dynamite is dangerous. Nitrous acid. And you're done. The key here is, do you know your ions? All right, looking here. PO4. PO4 is phosphate. All right, got to get rid of my 8. I ate something icky. Okay, so this one's a little bit different because we don't change it to phosphic, we change it to phosphoric. Okay, so it kind of resorts back to that phosphorus acid. So now you're probably wondering, all right, there's a 3 there. On the ones we did before that, there were no 3s. What you have to remember, and we'll look at this again in just a second, phosphate has a -3 charge, so our H's have to balance out with a +3 because H is a +1 charge by itself. Okay, moving on to the next one, we have SO3, which is sulfite. Get rid of our ite. We're going to bring back the UR the same way that we brought back the OR on our phosphate to make this sulfur. Now, ite, is that going to change to ick or us? Us. Sulfurous acid. So I brought this back in. All right, so I want you to go ahead and pause this. Do these two as an example. Remember to balance out those H's. Remember to change your 8s and ites to icks and us's. All right, so for this first one, SO4, remember, is sulfate. Gonna get rid of my 8. I'm gonna make that an ick. I ate something icky, and I'm left with sulfuric acid. Then here, carbonic acid. So carbonic is going to come from carbonate, because remember, ick came from 8. So come back to that. That is CO3 -2. If that's a -2 charge, I'm going to need 2 H pluses. So H2CO3. So let's do another example like this one because, right, we did not do one. So I'm going to give you another one. Let's say we have hypochlorous acid. Okay, so hypochlorous, remember that this OUS came from an ite, so this is hypochlorite. So that is ClO-. And what do I have to balance this out with? To make it an acid, it has to have a hydrogen. Okay, so I balance it out with H's. This was just a -1 charge, so I only need one of these. So we're going to have HClO. Now notice, I don't include any charges on here. That is not needed because how that charge is represented is being balanced out by your hydrogens. All right, let's look at, let's do bromic acid. Okay, remember ick came from 8. I ate something icky. So that comes from bromate. Remember, bromate is BrO3 minus. So what do I have to throw in front of this bromate? I have to put an H in front of there. How many H's? Well, it has to balance out with my charge. My charge here is -1, so I only need one H. So I can just leave it like this. HBrO3. Okay, let's do one more example here. Phosphorus acid. Sorry, that does say acid. OUS comes from ITE. So this is going to be phosphite, which is PO3 minus 3. In order for it to be an acid, I have to put an H in front. Now from this minus 3 charge, it has to be balanced out. So this is very similar to the ionic naming, like I said before. It has to balance out with my positive 1 H's. So that's why I'm going to need 3 of them. Okay, so important takeaways here. When you see acid, just put an H down. Get it over with so you do not forget about it. If you see an H with just a single letter after it, or you see the prefix hydro, those two things go together. If I only have one element after, so let's say this was the Cl, I need the hydro. If you get the prefix hydro, it means there's only one element after. So don't start putting the word hydro down every time you see an H. You have to remember, is that a binary where it's just an H and another one? Or is that going to be an oxyacid that has a polyatomic with my acid? Okay, so important to keep it differentiated from ionic naming, but also important for you to be able to determine which type of acid we are looking at. So go ahead, work on some practice problems, and let me know if you need any help.